just millivolts. Sure, everybody's seen Johnny Davro's video with this really cool toy here. Just thought I'd show some of the effects this thing does. Got it hooked up to 9 volts right now, and it doesn't just start on its own. It's got to have an outside source to give it a push, so that's what I'm going to do. Not enough. There she goes. Yeah, that sucker's spinning pretty fast. And down here, the 9 volts so far, we've got a regular light bulb that's going to the base of the transistor, control the current going to it, and the neon bulb glowing there is catching the back EMF. And that power gets fed to, at the moment, the meter, which you can see, if we can focus. Out of 9 volts, we're getting 14.5 out, and we can adjust that up and down, but that's not what's interesting to me about this. What is interesting is that when you take and hook up a car ignition coil like this, or first let me show you this real quick. Here's a battery, 9 volt. Just hook it up to the outputs here, and you'll see the energy begins to drain into the battery. The lights will go out, and you'll see a different effect even from the magnet. So it's charging the battery up. Now, I'm going to take, and you, let's see what I'm going to do. Just going to unhook it. I'm going to connect it back to the meter here. I want to show you what's interesting. I don't know if you guys know anything about Tom Bearden's work, where he talks about the dipole and how to try to keep it from destroying itself. Well, maybe this is kind of what he was talking about, not sure. But we're going to, coming off of the collector of the transistor, is actually going to the negative of the ignition transformer here, and the positive input power is going to the positive. And I'm just going to hook it up and watch what happens. See if I can back this up. You can kind of see what's going on here. Alright, so what we're going to do is just going to take and hook it up. Boom. Now this is 9 volts of power. Okay, the magnet's still spinning over there, but it doesn't even need to be running anymore for this to continue. And then, as you'll see, yeah, it's done. But look at here. Now those bulbs are only connected with one wire. Okay, only one of those are hooked up. Okay, you can even see the power. So there's 1, 2, 3, but the other ends are hooked to these other leads, which are sitting right here. These are the other 3 leads, and look at the power coming out of the where we would normally charge the battery. Have a look at this. It's 162 volts. Okay. Now what's really crazy, to me anyway, maybe somebody can explain this one to me, is when we take and connect the other leads to get even more light, like this. Okay, look. I'm gonna take it off, but see, you see that? All right, watch what happens when I hook the power up to it. Went up to 205 volts. Take it away, 171. So what I'm wondering is, you know, when we add a load, the voltage goes up, not down. And as you can see, things are just humming away here. And that's just one wire hookup. That's the one, just one side connected to each one. And then if I take and connect the other side of the fluorescent bulbs, pretty amazing. You might can hear that humming, and again, the magnet's not needed anymore. So I thought I'd show you guys that because I thought it was pretty interesting. Pretty interesting. I guess you guys know this thing, huh? Still trying to understand what role this sucker's gonna play in all this.